Hello everyone, in this video I want to demonstrate how the starter system works in a motorcycle. So the starter system consists of the starter motor, which is here, it's attached to the engine, the motorcycle engine. It consists of the battery. Here we have a 12 volt battery. We have the starter solenoid. We have the ignition switch with the key, and we have the starter switch, which we should all be familiar with. This comes off the right hand side handlebar of the motorcycle. Okay, so this is the starter button here that we press to start the motorcycle. Now we all know when we go to start our motorcycle, the routine that we go through on really all motorcycles is we turn the switch, the ignition switch, from off to on. Okay, so we now have power in our circuit, and then we go to the right hand handlebar and we press the starter button. So we press this button here and our engine starts. So what is actually going on in that process? Okay, I'm going to explain that. So the starter system consists of actually two main circuits. Okay, I'm going to talk about it I suppose in a simplified manner. I'm not going to talk about some of the extra switches that can be found in a starter system or in the starter circuit, some of the safety switches, for example. I'm going to talk about the main switches, parts and components that you're going to find on the starter system of really all motorcycles. So let's start off with the starter motor. Okay, so this is the starter motor. Now I have done a separate video on how the starter motor actually works. You can take a look at that to get a detailed explanation of how the starter motor actually gets the engine running. Okay, but for the purposes of this video, I'm just going to talk about how we actually get the starter motor, power to the starter motor. Okay, so the starter motor, as I've explained in my other video, is connected into the motorcycle engine through this gear here. Okay, so there's this gear pinion here. This is the output from the starter motor. So when we supply power to the starter motor, this gear should begin rotating, and this gear acts on some intermediate gears. I've actually removed the housing here, but here's the intermediate gears, and they act on the starter driven gear, which acts on the crankshaft, and it begins rotating the engine. So how do we get power to the starter motor? Well, power to the starter motor comes from the battery. Okay, so here I have just a small battery. It's a 12 volt battery, so it will start this particular engine. So essentially what happens is the starter motor is screwed into the engine casing. Okay, so there's two bolts here, so you probably won't see me in the video, it'll be out of view a little bit, but there's two bolts that sit at the back of the starter motor, and they screw in to the engine casing here. Okay, so they screw into the engine casing and they basically secure the starter motor to the engine of the motorcycle. Now they also have a secondary function in that they, the fact that the starter motor is screwed into the engine, it means that the starter motor is actually connected to the frame of the motorcycle through the engine, because the engine is secured to the frame, and the frame is connected via a wire to the negative terminal of the battery. So the negative terminal of the battery will be connected directly to the frame of the motorcycle. So that allows electrons from the negative terminal of the battery to flow. So they flow from the negative terminal of the battery to the frame of the motorcycle, to the engine casing, and into the casing, through the casing of the starter motor. Now, they will not flow unless there is a connection to the positive terminal of the battery. So this is what this lead here that comes out of the starter motor is for. It completes the circuit. So this is the lead here, which is essentially connected. If we do connect this to the positive terminal of the battery, so for example, then we have a complete circuit, and this will allow the starter motor to, or it will supply power from the battery to the starter motor, and it will allow the starter motor to rotate. Now the thing is that the starter motor, in that scenario that I've just described, it would be constantly connected, it would be constantly be a circuit from the battery to the starter motor, and it would be constantly rotating. So we do not want the starter motor constantly rotating. When we go to start the engine, what we do is we press this button here, which starts the motorcycle. Let me just turn it off here for the moment. And so we press this starter button, and we only press it for as long as the engine is trying, or the starter motor is trying to get the engine started. As soon as the engine is started, we take our finger off the starter button. Okay? So that means that we only supply power to the starter motor for only possibly 2 or 3 seconds. Okay? Generally. And we don't want to supply power. As soon as the engine is starting, we don't want to supply any more power to the starter motor. So for that reason, we cannot connect the starter motor directly to the battery. So what we need is some sort of a switch. Now, we could connect, this is actually a switch here. This little starter button is a switch. And you might think to yourself, okay, so why don't we just connect a wire from the positive terminal of the battery from the positive terminal of the starter motor to through this switch here, and connect that to the positive terminal of the battery. So we would have this connected to the switch, and then on the other side of the switch it would be connected to the positive terminal of the battery. And in that case, every time you press that button, you close that switch, and it would allow current to flow through the circuit, and it would allow current to flow through the starter motor and get the engine started. In theory that is possible, but that is not actually the way that motorcycles are actually designed. This circuit that I'm talking about is called the high current circuit, okay? And it's called high current circuit because a very high current flows through that circuit to get when the starter motor is acting on the engine of the motorcycle. Now the reason that there is a high current flowing through the starter motor is because it takes a lot of energy to try and crank the engine over and get it started. So that is the point of the high current circuit. Now because there is a high current flowing through that circuit, it probably is not ideal, because it requires, if you look at the leads here, it requires very heavy leads to carry that current. You probably can't see it that well, but it's actually, this full wire here is actually, it's all wire inside. It's much thicker than some of the other wires that are here. It's about 5 or 6 times thicker, okay? And it's 5 or 6 times thicker because it has to be able to carry that large current through the wire. So let's just install our starter motor back in the engine of the motorcycle. Okay, So what I'm going to do is, because I don't have a frame, I'm going to actually earth this, I'm going to connect the bolt, I suppose, in the engine casing directly to the negative terminal of the battery. Okay, and that means that the casing of the starter motor is connected to the negative terminal of the battery. So I'm just going to take a wire here. So I just have this wire. Now this wire here is actually quite a thin wire. This is not suitable for connecting being the earth wire, okay, but just for the purposes of this quick demo it will be sufficient, okay. But if you put too much current through this, the current that flows through the starter motor, if you flow it through this wire for too long, there's a good chance that you will actually, the wire will start to heat up because it's not large enough to carry that high current, and there's a chance that that wire could melt and ruin your circuit. But for the purposes of this demo, it's perfectly fine. So the starter motor, I'm just going to connect it back into the engine. Okay, so that's the starter motor connected back in. I'm going to take my wire, and what I'm going to do is I'm going to wrap it around this bolt. Okay, so it's going to be connected to this bolt, which is going to be secured into the engine casing. Okay, so this is my earth wire. Okay, now if I connect this lead here I'm going to demonstrate this high current circuit, and I'm going to demonstrate how it actually gets the motorcycle running. So I'm just going to connect this to the positive terminal of the battery, this wire here, this lead, and I'm just going to connect this quickly to the negative terminal. We're just going to we should see the starter motor rotating. Okay, so the current actually flows from the positive terminal of the battery. So the current flows through this wire here, inside the starter motor, out through the engine casing, through the bolt that's securing the starter motor to the engine casing, and then through this wire, and then back to the negative terminal of the battery. So that's the circuit here. That's the high current circuit. So let's talk about the second circuit in the starter system. So this is the low current circuit, okay, and it's called the low current circuit because it only carries a very small current. Now the low current circuit consists of the battery, okay, it consists of the starter solenoid. Okay, so this is the starter solenoid, which I'll talk about in a few minutes. It consists of the ignition switch, on or off, with the key, and then we have our starter switch here, starter button to get the engine started. Okay, and we also have here, this is just a simple fuse. Okay, so the fuse is just there for safety in case there is a short or too high a current flows through this circuit for whatever reason. This fuse protects the circuit. Okay, so the ignition switch here is just a switch, so it basically either closes or opens the circuit. And then the starter button on the handlebar of the motorcycle is just a switch as well. So when it's not pressed in, it is the circuit, or the switch is open. And when we press it in, it closes the circuit. Okay. Now it's mounted on a little spring. There's just a little spring behind it. Okay. And inside there is just little electrical contacts. Okay. You can hear two little You can just hear the two bits of metal tapping. Okay, so that means, so one piece of metal in this starter button is connected to the positive terminal of the battery, and the other is connected to the negative terminal of the battery. And when we hit the two pieces of contacts together by pressing it in, it just it closes that circuit, and it allows current to flow from the positive terminal to the negative terminal. So let's follow the wires. So the current flows from the positive terminal of the battery through this red wire, which is connected into the switch. Okay. Now the switch has a number of wires coming out, but there's two of them that I've connected up into this circuit. Okay. Now if we follow this switch here, okay, so it goes in through this red wire, it comes out through this black wire. Okay. So the current flows through the switch, back out through the black wire, and then the black wire is fed into this, as we can see here. The black wire is fed in here into this switch that's connected to the starter button. Okay? Right? So it feeds up to the switch, through the switch, and then there's another wire that comes back down here, which is the yellow and red wire. Now the yellow and red wire feeds into the starter solenoid, and from the starter solenoid it feeds up in through the starter solenoid. It's actually a switch itself, and it flows up through, or it flows out from the starter solenoid through this green and red wire, which is kind of fed into this black wire, which is kind of what we would call the earth wire, because it's connected to the negative terminal of the battery. No power will flow through this low current circuit when I press this button, unless this switch is on. So this switch has to be closed. Okay, so I turn this switch, the ignition is now on. That means that the electrical contacts are now in contact, and current can flow. Now when I press this button here, current, if I close this button, if I press on it, it closes the circuit and allows current to flow through this circuit. If you just take a listen, first of all, we'll just hear what happens when I press the starter button. Okay, and if I turn the ignition off with the key, and now I press the starter button, the only clicking we hear is in this button here. We don't hear any clicking from the starter solenoid. Now let's do this again. Let's turn the ignition on again, and let's press this starter button. Okay, so that means that our starter solenoid is working. So let me explain what a starter solenoid is. So inside this, if you look at it here, it looks, let me take this plastic casing. It sits in this is connected into the frame of the motorcycle, okay, and it's just a housing, a plastic rubber housing for the starter solenoid. So if you take a look at this solenoid, it's actually cylindrical, so it's just a cylinder, okay. So there's two wires coming into it through this low current circuit, and what happens is inside here the wires are actually wound up. So it's wound up, so there's many windings, okay, inside the two wires that feed in here. So it's actually one wire, but it's actually wound up inside, okay. And that means that when the current flows in through this wire here and out through this one here to the negative terminal of the battery, so this one's connected to the positive and this one's connected to the negative, so the current flows in through the positive, goes around the windings of wire that are all wound up here, and then comes back out through this wire here, which is connected to the negative terminal of the battery. When current flows through the windings of wire, it creates a magnetic field which acts creates a force which pushes on a piece of metal. Now this piece of metal is actually, this was my finger here, but there was actually a piece at the top of it. So it's actually a T-shaped piece of metal. So you have to think about this T-shaped piece of metal. When there's no current, it sits here, and when current flows through the wire windings, this piece of metal is pushed upwards, okay? So this T-shaped piece of metal. Now, the point of the T-shape is that when this piece of metal here at the very top, the top of the T, that moves up, and it actually connects with these two contacts here. So there's two copper contacts which are embedded in the top of the solenoid. Okay, so they have little bolts to screw on. So you can see they're a copper colour. And what actually happens is that the piece of metal moves up, and inside here, you can't see it from the outside, but inside here, these electrical contacts, or bolts, I suppose, they look like little bolts. They actually continue on inside, okay? And they're sitting just above that T-shaped piece of metal. And when that T-shaped piece of metal moves up, it connects with the two bolts. So as you can see, these two bolts are not connected at the moment. So there is no way that current can flow between these two bolts unless there is a contact made. That's the point of this primary circuit. Its only function is to cause that T-shaped piece of metal to move upwards and make a contact. Okay? Now at the moment there is no contact because this circuit is off. Now let me just place it here. It just wants to tip up. Now when I press this button here, let me just do it again. It must be off. Okay, turn it on. What you're hearing, that clicking noise, is actually that T-shaped piece of metal. It's moving upwards. Okay, when it knocks off the two bolts inside, it makes that clicking noise. So that's what that clicking noise is. Listen, you hear a second click. So here's the first one. There's the first click, and I have my button pressed. And when I remove my finger again, you hear it clicking, and that's because the contact, when the current's flowing through it, it connects up, it makes a click, it makes a contact, and when you depress the button, it clicks back again because the T-shaped piece of metal moves back down. So that's how the solenoid works, okay? And what's the point of actually this T-shaped piece of metal moving up and down? The point is to create a circuit, okay? So again, this is the primary circuit. Now if we go back to, this is the low current circuit. So we go back to our high current circuit, okay? So again, we will connect this to the negative terminal of the battery, okay? And what we're going to do is we are going to connect this lead from the starter motor. We're going to connect it to the I'm just going to turn off this switch, and I'm going to connect this lead. Okay, so on the end of this lead here, it has a little electrical connection which I can push on to the top of the solenoid. Okay, so it just fits on like so. Okay, and I take, there it is, there's a little plastic cover on it. Okay, it's just an insulator. So I take the nut and I screw that on, and I just tighten this on. Okay, and I'm going to put my little rubber cover on that. Okay, so that's the first bolt connected on the solenoid, connected to the starter motor. And I'm going to take this red lead that I have here, okay, and I'm going to connect it into the other bolt. I'm going to connect it onto the other bolt, and I'm going to screw it on. Okay, so there we have our red lead connected to the second bolt on the solenoid. Okay, now let's remember our high current circuit. So we want current to flow from the positive terminal of the battery. So this is the red lead is going to be the positive terminal of the battery. Okay, it's going to flow through this red wire to this terminal here, which ends on the bolt, and then from this connection here, this black lead, into the starter motor, through the starter motor, out through the casing, and through this black wire which is connected to the casing and to the negative terminal of the battery. So there's our circuit connected up, okay, for the high current circuit. Now, as I mentioned, this solenoid, these two terminals are actually, these two bolts that are connected into the circuit actually act as a switch, because there is no connection between these two, this red wire here and this black wire which is connected to the starter motor. Now the thing is, we can close that switch by turning on the ignition in the primary circuit, and then by pressing the button on the starter motor, or on the switch here. Okay, so that's how the starter system works in a motorcycle, and that's the point of the solenoid. When we press this button here, it allows the current to flow through this to low current circuit, which causes the T connection in the solenoid to move up and make a connection across the two bolts in the starter solenoid, at the top of the starter solenoid. And that means that current can now flow in the high current circuit. So here is the end of the starter motor. This feeds out from the starter motor, which connects up with the intermediate gears, which are here. And we can demonstrate that. So I'm just going to press on the button for the starter button. And you can see it rotating in here once I make that connection. And with the valve cover removed, let's take a look. I've reinserted the intermediate gears between the crankshaft and the starter motor, so let's crank it over. Now the engine will not start because it's not connected to the ignition, but we should hear the engine turning over, and we should see the rocker arms here underneath the valve cover that are connected to the valves. They should be going up and down.